Hey guys, my name is Toufi Saliba, and I wish I could be there with you in person at the Rare Bloom event. I was so looking forward to it for many reasons. I feel like our borders are getting thicker and thicker in this world. Unfortunately, 2022 and couldn't really make it there. As you can see, I am in Canada right now, and I couldn't really make it across the border. So here I am. I'm trying to present to you remotely, and hopefully, I can show you some contents that can be beneficial to everybody here in the audience. Uh, what I'm here to talk to you about is something that is extremely important for the future of technology and future of humanity. As much as many people they know that AI is becoming more and more into everybody's life, but very few know that AI is not currently as secure as it could be. And of course, the security of AI and AGI is going to become more and more important. Now, at the same time, if we were to present a model where let's just be nice and secure AI or AGI, uh, we would all agree that folks may or may not necessarily take it seriously because the majority of people on the planet they're driven by uh, either economics or certain motive or whatnot. So we feel with the hypercycle we have a phenomenal angle, and we're here to share it with you. And for those that they don't know what's AGI, artificial general intelligence. There's AI, there's AGI, which is basically the next step in evolution of AI. There's a general consensus between all AI scientists in the world that in order to get to ASI, artificial superintelligence, we will first need to get to AGI. And of course, as you all know, in the audience here today, you have some of the best AGI scientists in the world. And of course, you might see that they're speaking later, such as Ben Gortzel. And of course, you would see that many times we get to be misunderstood with some of the initiatives that we're trying to bring forward to the world. This, for example, is agnostic. It's HyperCycle agnostic. Currently, it's a Cardano sidechain. But many people, they feel it's like, oh, are you like on a Cardano side or an Ethereum side or on a Bitcoin side, whatnot. Frankly, science is cumulative, and we're trying to actually add this value to the entire humanity, and we're strong believers in what we're doing. Now, why HyperCycle? So, while many are trying to optimize for transactions between humans or humans and machines, and probably 6,000 projects they're trying to optimize for transactions. They tell you, oh, let's take care of like how people can pay for their coffee with their. Well, we have decided to optimize for transactions between machines. AI needs to subcontract other AI in a nanosecond setting, and the need for distributed computing in a fully decentralized setting, basically high security by design, is growing exponentially. So we feel like the vast majority of global transactions, and this is not just based on us, there are a lot of folks that they've done their numbers that, they're likely to exceed 90% by 2026. And currently, we're living in a time in 2022 that we're experiencing that shift where the vast majority of transactions that they happen, they're between AI and AI. So we're focusing on that tiny little thing. And like I said, we cannot take credit for everything that we're bringing together. A lot of pieces from like any science is cumulative. There's a lot of innovations: Bitcoin, Cardano, Singularity, Ethereum, and then all together. If you look at the Toda, I'm the author of Toda IP, and I'm a proud author of Toda IP, and it's effectively Toda IP. It's not something that it's like any of the projects that you hear that they may have some token or coin, doesn't have any of that. It's just effectively it's a communication protocol, but it's capable of getting us closer to that peer-to-peer with proper implementation, which we hope to accomplish here. And of course, there's a lot of innovations from the ERC-64 data structure, and there's something that is called the SATO server that we like to put that HyperCycle in it, which is basically building the synapses of the global brain. And this is extremely important. When I ask the audience in many different events that I speak at, you know that there's a race towards AGI. Every single entity in the world, they're trying to get to AGI first. Is it going to be Microsoft going to get there first, or is it going to be Google? Is it going to be Facebook, Tencent, Chinese government, US government? And there's so many different entities that are trying to get to AGI first. That is the race towards AGI. Today, we're living in that race. But I ask the audience, do you think a single entity is going to get to AGI first? Or maybe each and every one of those entities, they're more like the neuron in the global brain. We're building the synapses of the global brain. That's effectively a tiny little piece is what we're focused on with HyperCycle. Okay? Now, when I say peer-to-peer, how is it that that little piece can exist between computers, right? So we need to enable each and every computer with some components to have the other computer with those components so they can have a peer-to-peer exchange of value and information. And that's extremely important to not depend on a third party. By not depending on a third party does not mean that we eliminate the third party. We eliminate the dependency on a third party. Two different things. What do we mean by that? By eliminating the dependency on third party, perhaps we can enter a paradigm shift where third parties, they're providing service, and anything that's providing service that you can swap them, their evolution is likely to continue to be progressive as opposed to regressive, like we've witnessed with a lot of centralized services that exist around the world, that they come in as services and they become a dependency layer, such as banks, governments, whatnot. They don't necessarily evolve progressively most of the time. So how do we start with the HyperCycle? How about there's a piece of software that anybody can install that piece of software. We call it the HyperCycle computation node. Okay? Imagine anybody with any computer anywhere, they can install that piece of software. And that's precisely what we're working towards. What do you need in that piece of software? One thing that you need is something that is referred to as VM, virtual machine. How about we structure it in a certain way that is going to be installable, concise, and doing something that it's of value. Now, of course, if you were to have a VM, you can run a smart contract, for example. There's a lot of security that needs to be ensured, and there's something that we call it TM, transaction machine. Again, we're talking about like peer-to-peer here. You cannot like rely on Central Bank of England to do the transactions. Cannot. It has to be all part of this. So let's do this TM. We call it, effectively it is total IP that we use for the TM. So if you have a piece of software that you can install it and run it, and when you run it, you're adding value to humanity. We all know that this world of smart contract is less than 1% of developers around the world. As much as you can, look at each other and be like, oh my God, there's a lot of people in this event. But the reality remains less than 1% are involved in this smart contract world. So how do we touch the remaining 99%? What are they doing? What every single developer is doing? They're working on some things in AI. Okay, like every single developer, they're touching AI one way or another. Maybe they're not themselves building AI, but if they're building any software, that software is using some AI, whether it's narrow AI or whatnot. So how about we plug an AI module in there, and that piece of software now can enable some AI developer to provide their code if you want to run it now. Of course, that doesn't mean that this machine is going to have all the AIs. You'll have like one thing. You might select like, let's say, cancer research module or whatnot. Now, if you were to run this piece of software on your machine, you're going to get input. And when you get the input, what happens? You run. What do you do after that? Get the output. But will you give the output without getting paid? If you do, there is no incentive. How can you run your machine? How many machines and so forth? This is the cool thing about the TM, the transaction machine, that we've innovated with Toda IP for several years now. My co-author, then Tolliver, co-author with Toda, that's the entire paradigm shift. It's he also couldn't be here today, but effectively, this is something that is super cool. The moment you provide initially like the hash of the computation, and there's a method using certain methodology and zero knowledge proof or whatnot that the requester accepts that. So the moment you provide the computation, that the hash of it, or perhaps basically the output, that the hash of that output is precisely what they've agreed to, is precisely the exact same moment that you receive the payment. Okay, this is super cool. You don't have to wait for anybody. It could be a fraction of a second. It's instantaneous. Like that event happens. True atomic swap. Anyway, so we try to build some sort of visualizations to say that this is a HyperCycle. And when it comes to the VM, when initially I was planning to be there in person, one individual who's there in the audience, and Greg Colvin, was going to join me on stage, and we're going to actually talk about some of the innovation that we've done on the VM, of how we're able to get the virtual machine to run computing very efficiently. And there's a lot of formulas that we've used there and algorithms, and happy to share with folks if they were to reach out. But if Greg can hear me now and he's there in the audience, Greg, please stand up. Say hello to everyone. Greg helped the Ethereum VM back in the days, and I saw when Ethereum VM got 10x more speed when Greg helped them with that, and it's effectively demoed it, I think, in September 2016 in Shanghai. And him and I, we've been working for quite some time now and collaborating with some fabulous set of engineers and PhDs in math and computer science to get to something that is super cool when it comes to the VM. So if this is the HyperCycle node, how does it talk to other nodes? We use, something that is very familiar with the computer scientists, like a binary search tree structure, where it kind of like get to the point where there's a map from the Earth-64 data structure. Effectively, it's like a BST that folks, they know how to traverse it. And this is to get to the DDA, the deterministic distributed algorithm, also known as DDC, the deterministic distributed computing. Now, this is all cool. Let's jump into a little bit about like how do we get this to secure the Internet of AGI and get it in the hands of people. So how do you get that? So let's say you get it from a distributor, or you get it from the HYPC Corp. I mean, this is what we are. We're super open and transparent with everybody. We're launching this HYPC. It is a for-profit entity. We build software, sell software. Okay. Now, some people, they may want to be a distributor and get like a wholesale, price or whatnot, and we want to enable those things, and that's why we feel that October 22nd is the time that we actually want to release those components. So let's say somebody decides to be a distributor, they get, let's say, 512 of those licenses. What do you do with those licenses? Let's first talk about a single license. Somebody gets that license and they want to run it. Of course, everything here is like open source. Yes, it can be copied, so what? It's we're trying to enhance the world after all, but let's talk about that business model first and see if it makes sense for a single node. So if you look at one machine that you install it, you run it, and let's say it makes you 1 penny every minute. You've spent $100 on that, okay? It's making you 1 penny every minute. Might seem too little. If you do the math on that, that's about $15 a day. Let's say the AI developer collects about $6 or $7 from that 15, and then you spend some on electricity, some on network, some on maintaining your machine, and so on and so forth. You might still, have $3 or $4 in profit. Okay, well, that's great. If that makes sense, then we can perhaps have something that to offer. And maybe while we're building things, maybe we can offer this product at the discounted price, let's say $24 instead of $100. So let's look at the math of how it would work out on a $24. So you get a machine and you spend $24 on this machine, and there is something else that you might choose to add on that. And then you run this machine. This is how the machine looks like. Okay. The other thing that you add on it is like $13 worth of tokens. People in this audience understand the tokens. For those that don't, it's important to have an identity to this machine. This is what this does. Okay. So you get this machine to run. It's one node. You add so that's a total investment of $37. Let's see how it works out. So when you spend the $37, you run the machine to provide that service to the world. And when you run it, let's say you service so many computers, we call that computation. What's this analogous to? Let's say you go buy a coffee shop from or franchise from Starbucks, and you spend $1 million in that coffee shop. That's completely decoupled from the shares of Starbucks as a company. You just bought the franchise, and now you take care of that franchise. You service, let's say, 10,000 cups of coffees in the next 6 months. Okay? That's equivalent to computation here. How much computation this machine does. You get phenomenal reputation in this coffee shop. After 6 months, way better than it used to be before, and you convert the uptime. Used to be open 10 hours a day, you convert it to 24 hours. The combination of those things, almost any business person will tell you, chances are, if you were to say that now that coffee shop is worth $2 million, is believable. This is extremely crucial here because this is what we are doing for those machines, and the reason why they get a ratio of 2, this is basically the ratio that gets those machines to be selected. So if you spend $37, you ran them for 6 months, and John Smith decides to come and compete with you, John Smith needs to spend twice more than you because they need to get to that ratio of 2, so they need to spend $37 multiplied by 2. To get the exact same revenue as you do today. So what does that mean? That means that you are getting into something that is super cool, and it's basically the HyperCycle wealth creation. The uptime, factored by reputation, factored by computation. You started with something that's worth $37. It is now, worth $70 or $74. This isn't something that you do by just buying the thing and sitting on it. Of course, some people, they might think that like token or coin or whatnot, you can buy it for a certain price, and then it is not mutually exclusive. We are going to have that for investors, qualified investors. They have to comply with all of these things. Here I'm talking about something completely different, the actual product. Okay? The product, you run it on your machine, you take care of it, it starts adding service and value to humanity, and that's where this wealth creation come to exist. It's not something printing money out of thin air. This is real computation. You will have right here, you will have a proof of the computation, cryptographic proofs of how many machines you have service. You'll have reputation proof, you'll have uptime cycle, and so on and so forth. So this is cool, enabling. Imagine that after you leave today, you feel like, holy shit, is this real? That HyperCycle is going to enable every single machine across the globe to partake in this computation? And the answer is yes, we are. And this is what we are committed to continue to be working on. And if you do the math on that, and you can see how it would work out that, let's say, in 6 months, you continue working on that machine, you spend $37. The opposite of hardware. Hardware loses value. This machine and its reputation and so on and so forth, it's going to have a lot more value, because if John Smith is going to come in 24 months to get the exact same revenue as you, they're going to have to spend $384. And feel free to do the math yourself. This is effectively, you're going to consume a lot of electricity and a lot of other costs, but that's effectively the value of the machine. The one statement that I'd like to leave you with is that running AI machines is likely to be the #1 industry in the world. And with value add to humanity is something that is phenomenal, we take pride of. And now if it can make you money, that's even better. How about that, Every single student in any university, they can have a piece of that and they can partake in this business perhaps. This is super cool. So, without further ado, I would like, before I get going here, of course, those of you that are available in the audience, you get to meet some of the fabulous people available amongst you. And like I said, Greg Colvin is there, Dr. Ben Gortzel is there. Not sure if Dan is able to make it, but so far it's been very difficult. It's also Robert Moore, who's also double PhD, couldn't really get his passport in time, waiting until January. Fabulous team, super awesome to be working with them. We have also some real use cases to showcase to folks of why the real world need this. Please find Greg in the audience, find Ben. I truly wish I could be there with you in person. Maybe next time. Thank you very much.